Yo, what's up, Sci Fam? It's your boy Nickel here. And today we're going to learn about a guy who came up with an atomic theory back in the early 1800s. His name was John Dalton. And John Dalton came up with these 4 ideas of a way to describe all matter in the universe in terms of atoms and particles. Now, this was all revolutionary at the time. But today, it's some things that maybe you've actually heard before. Maybe not. But this will be a good way for us to start understanding how atoms make up molecules and really how atoms make matter in our universe. So, your science notebook page, it should just take 1 page. We're going to title it Dalton's Atomic Theory. And there are 4 ideas in Dalton's atomic theory. So, make sure you have room for all 4. Let's get started. Dalton's atomic theory first says that all matter is made of atoms, which are themselves indivisible. So when you think about like one nation indivisible, when we talk about the Pledge of Allegiance for the United States, it's like the 50 states are going to stick together no matter what. And that's what indivisible means here with atoms, is that an atom in itself is indivisible. It's not going to split apart, except in a nuclear reaction. And this was something that was unknown at the time. But since then, we've been able to use scientific processes to actually split atoms and devise them, or cause them to split apart, which would be meaning that they're divisible. So all matter is made of atoms, which are indivisible, except in a nuclear reaction. That's like an atomic bomb, or even in a nuclear reactor, which we use to get electricity in some areas of the United States. So the main thing is matter. It's not going to matter is made of atoms, and atoms are not going to split apart. Second, all atoms of a given element are identical in mass and all other properties. So if you have an atom of the element nickel, it's going to be just like every other single atom of the element nickel. An atom of the element carbon is going to be exactly the same as every single other carbon atom. So that's why the periodic table of elements is so helpful. So let's take a look at sulfur. So the element sulfur has 16 electrons, which is how it gets its atomic number. Its atomic symbol is the letter on the periodic table that represents sulfur, which is just the S. And the weight of 1 mole of sulfur, meaning like 1 unit of sulfur, weighs 32.06 units. So that's only important as we compare other elements. So let's look at an element like tungsten. Tungsten has a lot more electrons. It has 74 electrons. So its atomic number is 74. Its letter that kind of represents tungsten is the letter W. And tungsten weighs much more than sulfur does. It weighs 183.84 units. So every single atom of tungsten will weigh the same. Every single atom of tungsten will have the same number of electrons. The same is true of sulfur. Every single atom of sulfur will have the same number of electrons as the last atom of sulfur. So we can predict and expect to have these types of qualities if you have an atom of these different elements. So let's do one more. Let's think about silver. Silver has 47 electrons, and it has a weight of 107 and 87. So 107.87 units. So again, it weighs less than tungsten, has less electrons than tungsten, but more electrons and more weight than sulfur does. And every single element, or every single atom of silver is going to be very similar. It's going to be the exact same. It's going to have the same electrons, same mass. The atomic symbol for silver is Ag. So the fact that every element has a predictable and reliable mass and number of electrons is one of these theories. And so we can always predict that if it's carbon or if it's hydrogen, we can always know how many electrons it has and its mass and other properties about it. All other properties are all the same. Swag. Number 3. Compounds are combinations of two or more different types of atoms. So let's look at some examples. Carbon dioxide is a combination of two atoms. It's carbon and oxygen. But there's two oxygens attached to the carbon, so we call it CO2. But since there's carbon and oxygen, there's two or more different types of atoms, which means that is a compound. Water has hydrogen and oxygen. It has two hydrogens connected to the oxygen, and so it too has two different elements, hydrogen and oxygen. So those are two different types of atoms. Glucose is another example of a compound because that's C, H, and O, carbon, hydrogen, and oxygen. It has 6 carbon, 12 hydrogen, 6 oxygen, C6H12O6. So this is also an example of a compound because it has two or more different types of atoms. However, oxygen, even though it's a molecule, but it's not a compound. It's not a compound because oxygen is just O2. So even though there's two atoms connected to each other, it's only made of oxygen. So since it doesn't have different atoms stuck together, it's not a compound, it's just a molecule. So compounds are combinations of two or more different types of atoms. And Dalton's final atomic theory, number 4, is that atoms are not created or destroyed in a chemical reaction. They are only rearranged. And this might remind you of the law of conservation of energy because energy is not created or destroyed. It's only transferred from one form to another. It's the exact same thing. The atoms are not created or destroyed in a chemical reaction. They just get rearranged. So if you have A and B connected to each other in a molecule here, and you add some D to it, and this is the other molecule, or the other atom, it's not going to create something new and different. Letter Z, it's impossible. The only options are that A could connect with D, B could connect with D, or maybe A is by itself, B is by itself, and D is by itself, or maybe A connects to B, which connects to D. So there's only these options available because we only started with A, B, and D. So if we look down here, if we have a circle connected to a circle and we add a star, the only options are that the circle can connect with the star, and if it does, then there's an extra circle left over. So if you start with certain qualities, you're going to end up with those same qualities just rearranged into a new pattern. So we're not creating or destroying any new atoms. We're creating and destroying different molecules, but molecules are made out of atoms. So here's an intro into some of the basic ideas about atoms and how atoms make up all of the different types of matter, and also some of the things that we can rely upon, knowing that atoms make up different types of matter and that all elements have their own qualities, and all atoms of that element will always have predictable qualities. All right, I'll see you on the next one. Peace.